If the product rule taught us anything, it taught us that sometimes derivatives are a little bit tricky. Specifically, it taught us that if you have two things being multiplied together that both contain variables, you need a specific rule to take that derivative. But what about other operations besides multiplication? Well, if you're adding two terms with variables, you can derive those terms separately with no problem at all. It even works with subtraction. However, if two terms are being divided, you'll need to use another special method called the quotient rule. It's called that because quotient is just a fancy word for division. But very similar to the product rule, it's another thing you have to memorize. Just like the product rule, the quotient rule has a very specific pattern that it follows every time. Before we go into the exact definition of the quotient rule, let me show you an example first. Let's say you want to find the derivative of f of x is equal to the fraction sine of x divided by x squared. Well, we know we need to use the quotient rule because we have two variable expressions being divided. Here's how it works. The derivative, f prime of x, will be equal to the bottom of the fraction left alone times the derivative of the top of the fraction minus the top of the fraction left alone times the derivative of the bottom of the fraction. And we're going to divide that entire quantity by the bottom of the fraction squared. So what does that mean? Well, the bottom of the fraction left alone is x squared. The derivative of the top will be cosine of x. Leave that minus alone. Of course, the top is sine of x. And then the derivative of the bottom will be 2x. And then the bottom squared is x to the fourth power. To be extra neat, we can go ahead and simplify by factoring out an x that everything has in common in the numerator, and then canceling that out with an x in the denominator. And this is our final derivative. Let's go ahead and define the quotient rule in official math terms. If some function h of x is equal to f of x divided by g of x, in other words, h of x is just some function defined as the quotient of two other functions, then the derivative of h of x is equal to g of x times f prime of x minus f of x times g prime of x all over g of x squared. Now, what does that exactly mean? It means basically that the derivative of h is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. That's the quotient rule. Now you go ahead and try one. What's the derivative of f of x is equal to e to the x divided by cosine of x? Now, in case you're not sure what to do, here's a couple hints. The derivative of e to the x is e to the x, and the derivative of cosine of x is equal to negative sine of x. Go ahead and work it out on your own, and once you've decided what you think the answer is, click the appropriate button. Congratulations, you got the problem right. Pin a rose on your nose. One word of warning. Some students forget that the quotient rule has a denominator portion to it. They get all wrapped up in that long numerator when you take the bottom and the derivative of the top and the top and the derivative of the bottom, you subtract them. By the time they get all that work done, they forget that they still have to do the bottom squared. So don't you forget. The quotient rule does have a denominator in it.